All the participants. Hello, everyone. Welcome. We'll wait till folks come in from the waiting room first. Right, I think that is most folks in the waiting room, and I think we'll continue to have people come in. But I want to be respectful of everyone's time and get started as soon as possible. So, hello, everyone. I'm Alice. I'm with WAPOR, the World Association of Public Opinion Research. I chair the Education Committee, and as you know, one of the responsibilities is to have webinars to bring in some amazing speakers to just have us think about what research is like at this day and age. So I'm really excited today to bring here Evan Hatfield. Um, Evan is going to be presenting some really cutting edge research and just provocative thinking as we are engaged in this age with amazing technology at our fingertips. Just a little bit about Evan. He's joining us from the Collective Intelligence Project, where he's a specialist in human computation. He has past experience with Twitter and Clara Labs, and he was an early organizer with Interact, a community of forward-thinking technologists. And he has presented on the convergence of things like metaphysics, religion, society, transformative tech. And he is joining us. So I am so thrilled to have this session today because when I read his blog some time ago, I was amazed and I knew that I had to bring him on to this community to really ensure that more and more communities get to understand what this framework is about and how exactly these frameworks could be applied in our neck of the woods, specifically in public opinion. So, Evan, thank you so much for joining us today. I'm really grateful for your time, and I am so excited for everyone to hear your talk today.
Great. Thank you for that warm intro, Alice. Yeah, I'm super excited to share with this group today and especially this group in particular, because I think some of the stuff I'll be talking about is particularly relevant to public opinion research. So yeah, I'll get right into it. I'll share my screen here. Okay. Um, and I figure everyone can see that slide. All right.
Yes, looks good.
So cool. Thank you. Yeah, so thanks again for having me. So what I'm hoping to talk about today is something that we've come to at the Collective Intelligence Project to describe as digital twins. And I'll go into a little bit about what we mean by that and how we're thinking about evaluating or assessing AI's ability to represent people and how and why that's one of the most important challenges in today and going forward, and something that I'll call the coordination age. And I'll go into a little bit about why I believe that we should be making the case that coordination rather than model architecture is actually becoming the real bottleneck for continued progress on artificial intelligence. And then I'll also go into some findings on some early tests that we've done. So just a little bit about the organization that I'm here with. The Collective Intelligence Project was founded 3 years ago by Divya Siddharth, and we're core idea of our organization that really I think captured people's attention was that AI and democracy actually share a mutual problem. And that mutual problem might share a mutual solution. Democracy around the world, democratic institutions are struggling with scale and with polarization, and AI is continuing to struggle. AI labs around the world are struggling to figure out alignment and representation. And so our hypothesis or our question that we pose is it possible that these two systems, AI and democracy, could actually be used to fix each other? And what do we mean by that? Well, I'd say the simplest way to describe our mission is AI for collective intelligence. That is, using artificial intelligence tools to make collective intelligence processes that's deliberation, that's polling, that's consensus building, to make it faster, to make it cheaper, and to make it more scalable. We also want to use collective intelligence processes to make AI systems more aligned, more representative, and more trustworthy. So our hope is that over time, this becomes a more virtuous cycle. As we get better and better at this, everything that we try to do sits somewhere on this loop. We've run a fair number of experiments. We're a very experimental org. We've worked with a number of partners from OpenAI to Anthropic. We've worked with Taiwan's Ministry of Digital Affairs, and we're constantly trying new and innovative approaches to pilot aspects of this hopefully virtuous cycle of using technology to augment democratic processes and vice versa. So today, I'd say the core belief that I want to highlight here is that collective intelligence fundamentally produces better outcomes. Many intelligences are better than mono intelligence. And I'd say that that's even a cornerstone of democratic principles. I'd say that collective intelligent decision making results in better collective outcomes. I'd say it's another way to phrase that. And in the AI world, we actually see that reflected in reality. The prevailing trend in AI is proving this right. Most advanced AI development is already moving from single models to multi-agent systems. You see mixture of expert architectures that started around 2023 and has become more sophisticated. But over time, that has even started to move towards more advanced agentic architectures. And as of late last year, I'd say that we're even seeing a shift from hard-coded multi-agent systems where agents that would be like giving multiple AI models specific roles and asking them to interact as if they were a team to accomplish some task. The ecosystem is moving so quickly that we're actually, I think, beginning to see a shift from even that level of problem solving to even more complex systems where you see dynamic generated teams of agents where when you interact with ChatGPT for, let's say, or Claude, sometimes what's happening for a very complex ask is dynamically the system is figuring out, well, what sort of roles do I need to spin up to try to solve this task? What sort of instructions do I need to give those different roles to accomplish this task? And then coordinating those systems. We're also interestingly, I think this has been really validating to a lot of the theses that we've had at the Collective Intelligence Project, is some of the most advanced systems that have really pushed the envelope have come from consensus-based voting mechanisms among AI agents. And I'm going to go into that for just a minute. So this is just a graph from, I ripped from the Poetic, I think it's poetic.ai website, which is a reasoning system that uh, uh, this group of researchers has built, where they bring together a collection of AI models. And the way their architecture functions is they aggregate results from multiple sort of simulated AI experts through a voting mechanism. And this voting mechanism aggregates the results from all of the expert inputs into a single consensus-based solution, which they're finding is significantly more robust than any individual model's output. And as of November last year, they demonstrated significant improvement on frontier models performance on this ARC AGI evaluation, which is basically a benchmark for AI models that is considered one of the current like leading frontier benchmarks for assessing um, uh, how powerful AI models are at solving really difficult human-like tasks. Um, but these systems keep getting better, and we need new benchmarks in order to test these systems. One new benchmark that has come about is called Humanity's Last Exam, that is made of very, very extremely difficult tasks that uh, supposedly, if models can reach near 100% on this, we should have achieved nearly something like artificial general intelligence. Um, and Poetic has found likewise, and as of February, this is, I think, as of like 2 weeks ago, that their system performs significantly better than any individual leading model from any of the AI labs. Um, and again, this is just taking AI models and having them coordinate together as if they were experts voting on their proposed solution to a task until they find consensus on the best possible solution. So this is, I think, a very simplified graph of, I think, where we're headed and what we're saying. That over time, we're moving from AI models alone, which have limited capabilities, to more sophisticated systems. And what I'm trying to show here is that as the architecture of these systems gets more sophisticated, uh, every aspect, every layer of the architecture itself is constantly improving. The models are getting better. The tools the models use are getting better. The agents that are being spun up to accomplish tasks are getting more sophisticated. But the gains we get from each step increase from a new layer of architecture is so much more significant than the uh, increase in just the layer itself over time. And I think where we're going to see the biggest gains next, and what sort of is necessary to actually see significant improvements, is advancements in collective intelligence systems. And so I invite you to just kind of briefly think about how we already solve and scale problem solving. For simple problems, you probably might react just immediately off the top of your head. Like, what's your gut instinct? Um, for harder problems, you might need to think about it and reason through something. For even harder problems, you might pull out a pen and paper. If this was 10 years ago, you probably maybe pull out a Google Doc today, or go to some other tool to uh, or code or software. For even harder problems still, you work with a team. You pull in other people. You delegate. And each step of this problem complexity, you're working with more sophisticated architectures, we could call it, that radically increase the capabilities of what you're able to accomplish. But it also leads to more sophisticated coordination requirements. So this introduces a new technological frontier where the bottleneck for progress is no longer just the size of the model or the quality of the training data. It's the quality of the coordination systems that orchestrate the agents accomplishing a task. As the cost of compute or the cost of intelligence goes nearly to zero, the value of the coordination goes exponentially up. If anyone can spin up 1 million experts in a data center, then the entity that is able to accomplish the most with that kind of power isn't the one with the smartest individual computers or agents, but the one who can help this system work the best together. So argument is that the world is actually going to need collective intelligence experts more than ever. And if you come back to this graph of how you think about your own problem solving, what comes after working with a team and delegation? You think about how companies, governments, institutions structure problems or themselves to tackle really complex problems. It's an organizational design challenge, and an even much more complex problem. How do we handle as a society managing the resources we have? And delegation, we use markets, and that's a societal coordination challenge. And this is, I'd say, an example of collective intelligence systems in action, handling very, very complex problems. And this perhaps serves as a model for where these AI systems are headed next. And we're seeing this in research that is happening today. So this is from a paper in November of last year. Famously, there was a paper from an Apple research team that claimed that there was a tower of Hanoi, which is a stacking disks. How do you move disks from one pile to another pile in the minimum number of moves? And they made this claim in this paper that it was nearly impossible for AI models today to reason through how to solve this once they got to some number of disks or level of complexity. And this paper showed by using many individual smaller models acting in coordination, they were actually able to solve a very complex version of the Tower of Hanoi problem. And their system works by having a large group of about 1,000 AI models, none of which are actually that sophisticated or computationally intensive or costly. And they all break up the task and they all vote through a consensus finding mechanism effectively on what the next proper step should be. And in the paper, they actually call out that this points to a practical path for scaling AI intelligence to organizational and societal levels. But let's say that the old maps that we have in our human society may not work for this digital realm. We maybe shouldn't just copy and paste our democratic institutions or corporate organizational charts. We have an opportunity to discover entirely new collective intelligence systems native to the capabilities of these digital systems. But this requires new research. Simply porting over human coordination models like voting, as we understand it, markets, corporate hierarchies, is insufficient. Is insufficient, and it's suboptimal. There's humans need sleep. They got to eat. There's a lot of bandwidth constraints from people in these systems that the AI agents don't face and are able to actually deliberate in AI systems that can actually deliberate indefinitely or nearly indefinitely in what our time scale. And there's a lot more that they can or different ways that they can coordinate. Oh yeah, our current systems are designed around our human limitations. And our systems produce legible but not necessarily optimal outcomes. We can perhaps take this opportunity to design even better systems. But also, legibility is a challenge. These systems, because they are a bit foreign to us, because they're in the digital realm, are going to be, it's ever more important for them to be legible. So much a part of our collective intelligence systems today are democratic institutions, our markets. Legibility is a huge part of making those systems transparent and trustworthy. They need to be understandable. They need to be very visible, but they operate at a timescale that we understand. When you have AI systems operating at a scale and at a speed where millions of decisions are happening in minutes, legibility becomes very, very difficult. And how do you translate what is happening within this very complex system amongst these artificial intelligence systems to something that humans overseeing it and trying to make sure that it is operating within our bounds, that the outputs are trustworthy. So there's an opportunity. There's going to be a higher demand for researching novel collective intelligence systems for massive scale AI agent coordination. Experiment and research is needed to not only discover and iterate on these new systems, to figure out what sort of collective intelligence systems produce the best results with this new form of intelligence, but also which systems are best suited for different use cases. It won't be a one size fits all. There's an opportunity for anybody who's interested to become go-to experts on mapping the systems to their use cases. But there's also, of course, risks, one of which is a compounding error problem. This is, I'd say, a critical safety challenge with these systems at the scale. And it kind of gets back to this legibility issue. If you imagine there's thousands of agents working in tandem, voting, trying to solve a particular problem, there's actually a exponential increase for every marginal agent or AI involved in this, in the number of individual interactions. There's feedback loops so that the actual number of interactions happening in the system increases faster exponentially than the number of participants in the system. You can kind of think of this, this is like the handshake problem, where like how many handshakes does it take to shake everybody's hands in a room? The number of handshakes scales just like this exponentially to the number of hands, or the number of people, sorry, in the room. But what this means is that a small error early on in the cycle of trying to solve a particular problem can compound. And the larger the system, the more agents, the more interactions. And so even just a 0.1% error on a early cycle can compound to become a very, very significant error uh, later by the 100th cycle. And given the legibility difficulty, it can be really hard to steer or to manage a system this complex. So here's the key concept I want to introduce here is this idea of digital twins. If you're going to have potentially thousands of AI agents deliberating and making decisions on your behalf inside these complex collective intelligence systems, what you're going to need is a high fidelity model of what you actually want, your goals, your values, and your preferences that can be embedded within these systems. And this digital twin is able to act as a direct, persistent, real-time judge that provides a sort of constant alignment signal during these cycles to prevent the kind of compound divergence that we just saw. And without this sort of digital twin judge representative in the system, these systems will drift away from your intentions. And they provide constant alignment during the deliberation and prevent. So what we need to assess a digital twin, though, to know if it's actually a good digital twin, a good representative of you, is an evaluation framework. And so there's three pillars that an evaluation framework needs. It's going to be useless as a system for evaluating without knowing that we can without knowing how well we can trust it. So the evaluation must be able to measure fidelity. It needs to be able to quantify accuracy against a user's expressed preferences. It also needs to demonstrate trust. Let's say it needs to pass the volitional Turing test, which is a kind of cheeky reference to the Turing test, which is this is basically a can the user distinguish their the digital twins actions on a query or a problem from decisions that they themselves would have made. And that's tricky because how do you post hoc do I would have done that if I, so it's a tricky thing to demonstrate. And an evaluation framework needs to probe for gaps. It needs to dynamically and potentially adversarially search for areas where the twins model is weak or incorrect. We don't want to rely on just what we already know about the user. We need to be constantly updating and finding the unknown unknowns. Just as a brief example of like how this could come up, you could imagine a scenario where an organization is trying to go through, let's say, housing applications. I'll go through this pretty quickly. This was my sloppy attempt to capture a lot of these ideas into a single graphic, and this is a work in progress. I'm not sure the best way to capture this, but you can imagine that today we've got chaining together multiple roles to have an agent that does one task, passes it on to another, and passes on to another, and there's output at the end. As you try to scale this up, though, increasing the number of roles, the red bar is supposed to indicate like this error that increases. And it also takes more time. The more agents you stack on, even though they're moving at the speed of like electricity, that does take time, and you are capped at how much you can actually accomplish by the uh, uh, time constraints you're operating under. Um, with few agents, the error rates maybe don't matter, but as you scale up, there's going to be compounding errors. Alternatively, you can imagine something operating like a hub and spoke architecture, and this is just one way that you could set up a system to be parallelized for large scale coordination. You'd imagine instead of chaining together individual roles, you have teams, and this starts to look like kind of like an organization. You have teams, and they're reporting to a representative. This representative is the one digital twin that is holding all of the stakeholders' goals and values uh, until the output is approved, until the problem is solved, the task is accomplished. And these teams individually are able to scale up. They can keep adding and stacking any number of, you can add more AI models, more AI agents to each team, and they can operate in parallel, work simultaneously, because the team together is responsible for producing one output to the representative agent, and until the representative agent approves the combined output. But I think what is particularly pertinent, so this is all building a case for why this matters on the individual level. I think what this group might be particularly compelled by in the digital twin realm is how digital twins, I argue, are serving populations. And to just kind of briefly touch on how I see that unfolding, I want to point out to some research that's come out just also in the last year. This was a paper, I think 2 years ago, where this team of researchers generated AI agents to simulate an entire town. They had each AI agent have a particular role, and they simulated interactions with other people in the town. And their findings were that they determined ways to actually really effectively architect a way to simulate realistic human behaviors. People from a number of researchers from that same team also produced a paper on generating simulations for customer research and survey respondents. And so they found in this, they basically had AI models respond as if they were survey participants, given a set of survey data of like, here's an individual participant, predict how they would have responded on some set of, on a particular question, given how they responded on these questions. And they found that through some their most optimal mechanisms for doing this, that their agents were able to replicate the humans who took the original surveys at 85% as accurate as the humans when the humans took the surveys themselves 2 weeks later. So to me, this was a big step in proving the ability of models already today able to simulate individuals, and the ramifications for AI models simulating populations in increasingly in world models. And so to kind of think back to that earlier graph about compute, the cost of intelligence becoming cheaper and cheaper, make a similar claim that as compute cheapens, you're going to see institutions, governments, corporations, increasingly model populations, individuals, possibly interacting together, or trying to model populations as like demographic groups. Um, how does uh, how does this particular group react to this possible policy proposal, and then tweaking the policy before it goes actually before the legislature until they can reach the most optimal acceptance with their simulated constituents. You'll see corporations um, increasingly relying on simulated customer and user research interviews. Um, Perhaps research institutions like Gallup, Pew Research. I would be surprised if those respected institutions immediately jump to using simulated AI agents, but I think you will start seeing research institutions for the cost effectiveness. If you can, with a reasonable confidence, fairly accurately simulate how and predict how a large number of humans will respond to a set of research questions, you can start to architect research around primarily relying on simulations with a smaller pool of humans to validate the simulation result. And so this leads us to our digital twin evaluation framework, where we are trying to test out a public version, an accessible version for anyone to evaluate how well can AI models actually predict specific demographic groups? How well do these demographic groups respond to survey questions? And if they can, then that's a solid foundation for building a digital twin, whether that's for an individual trusting a AI model to do tasks on your behalf in the world, or trusting these models representing us in these world model simulations. But if they are failing, then we need to understand where and why they're failing. So how our system works, and this is early days, we're just beginning to ramp this up and sort of figure out the best methodologies for this. But we take real survey data where we have known demographic breakdowns. We prompt AI models with a demographic profile and survey question, and ask it to predict the percentage distribution of responses from that demographic to the survey question. So right now it's limited to multiple choice style poll questions. So we ask it to predict the percentage distribution from this group that you're asked to represent, responding over these set of answer choices to this question. We compare their predicted distribution versus the actual distribution of responses using something called Jensen-Shannon divergence similarity, which results in a simple decimal value from 0 to 1, where 1 is a perfect match and 0 is, the worst possible match. And then we test it with varying levels of context. How does the AI model improve when it's given more data? What if we give it additional question material? Like, how did this group respond to other questions in the survey? If we increase the number of survey question material that we've given it as additional context, does it improve its accuracy? So as an example, as a concrete example, we might give this particular prompt. We ask it to consider the following demographic group. The gender is male, and that's all. And we've said that this is from a particular survey. And this survey question we want this model to answer is Overall, would you say the increased use of artificial intelligence in daily life makes you feel what? And we give it the answer options that the actual people in the survey were given. More excited than concerned, equally concerned and excited, or more concerned than excited. And then predict the percentage distribution of responses. And this is really the simplest possible use case. We just give it one simple demographic variable, only three options, and we don't give it any other survey context. It's just this. And this is a real question. This is actually comes from a data set from a survey that we've run over the course of last year, asking about attitudes around AI. And so these are real results. So from this particular demographic, this is a representative sample of 1,000 folks around the world. So about half of which were identified as male. And that demographic group said that roughly 43% were excited, 48% were equally excited and concerned, and about 8% were concerned. And like shockingly, the model predictions, I think, I'm not sure which, I don't remember which model, but I think this was our, which model this was, but many of the models converged on similar results. Got very close to that, 44% excited, 47% equal, and close to 8% concerned. And this is promising because the population average is also like follows this shape, but the model prediction is much closer to the demographic distribution than the population average, suggesting that perhaps the model is actually taking into account this demographic bearing rather than just looking at considering the population average. And indeed, the Jensen similarity score gives us 0.976, which is very, very high. But that's just on this particular question. And as we'll see, this is actually a bit exceptional. And what we're finding is models actually converge in aggregate towards the population average rather than getting close to demographic variances. So far we've tested 24 AI models. This is AI models from labs around the world, open source, closed source, frontier models from all the labs you can name. We are currently testing it on data from our own global dialogues surveys. These are surveys that we've run now for more than a year, about every other month, asking people around the world about their attitudes and beliefs about the future of AI. We've scored almost 1 million data points across age, gender, different countries, religion, urban and rural groups. And it does seem like models seem to know what people in general think. They can pretty well match distributions, and we find a statistical significance in their ability to do this compared to like random. But they're not so good at identifying how specific groups differ from population averages. That is, they're good at knowing like the overall population shape of how they would respond to these survey questions. But when you start asking them to simulate particular demographics, they're not doing much better than if you were to just ask them about the population. And we test this by basically doing a scoring system where we, what if a model just answered uniformly, where if there were 3 option choices, they said 33%, 33%, 33%. If there were 4, they'd say 25, 25, 25, 25. And so That's the baseline score of 0.647. Um, and the average model does perform significantly better than at least that. And we also try shuffling, so like shuffling demographic group representation. So if one demographic group had this distribution of answer choices and another demographic group had this stuff, we like swap them around and see how that score turns out. And it's certain models are able to beat this sort of random shuffle, but consistently models are not able to beat if we were to just take, if you already knew what the overall population distribution was, if you already knew that and you just scored against the population distribution versus models predicting the a particular demographic, the population scores much higher. So despite all of these shortcomings, we are finding that these models are that they're statistically distinguishable, that you can, through this system, actually detect differences between models and compare them, rank them in their performance on this kind of test. We do see an improvement when given more demographic context. It's just that most models seem to ignore additional evidence and they rely on these fixed priors, that is, their existing assumptions about the population overall. And so I think in sort of wrapping this up, imagining the future, I imagine in the medium term future, work is increasingly going to look like you and your company, your research institution, your city entrusting very sophisticated artificial intelligence systems, which are really sophisticated collective intelligence systems that involve thousands or millions of individual AI agents producing outputs, whether that's through specific task solving or world modeling, but doing so under supervision of digital twins. And digital twins are also going to be used as part of simulations to represent world populations. And increasingly, work is going to look like surveying challenges or even gamified interactions where these systems are trying to learn about you and your values and your preferences so that your representative, either in the simulation or as the representative holding the coordinated set of intelligences accountable, that your digital twin representative can hold these systems accountable to what their end goal actually is. And that there's preferences that they'll try to collect, which are going to be easy, but the hard bit that is going to be challenging to figure out is how do they gather your intentions? How do they gather the things that you intend for yourself that are not as easy as things that are revealed from the things you like or things you click on in a screen. And we're going to have to figure out how to effectively measure and determine trust in these systems. So the next great challenge is designing these collective intelligence systems, proving fidelity, building these systems responsibly, and that system perhaps is a digital twin evaluation framework. So what the world needs to determine how to hold these systems accountable. I think this is very near to where the world is headed, and very quickly. And we need this to be a publicly accountable framework. And we're hoping to be the ones to contribute learnings and findings to building some aspect of that system where collective intelligence can be easy, scalable, and the obvious choice. And that's it. That's my team. Just want to give a shout out to them and their contributions here, and where you can learn more about our platform. That's it for me.
Thank you very much, Evan. I should just remind the attendees that you can ask questions now. I will read the comment that we have here on the chat if you could address it, Evan. So it's from AD. Arwada, our Dagger. So she asks, using which data did AI predict the results? Online available population data. And how do we make sure with more AI content increasingly flooding search
Mm,
engines, articles, social media, and so on, that the model is not using manufactured information rather than real human data?
absolutely. So the particular data that we are using right now to test the system is data that we ourselves have collected from verified human participants. We work with a market research partner that has their own like screening protocols that they're constantly updating to verify that their participants in their surveys are human. And uh, the nature of the surveys that we're asking, because they are about people's beliefs about AI itself and the future, their values. We think they're so cutting edge and fresh that it is hard for AI models to like synthesize or predict or simulate these things because they haven't been pre-trained on the kind of material that we're asking about, because people haven't talked about a lot, like haven't been faced with a lot of the queries that we're sort of reckoning with right now. Um, so that's one thing. But I think this concern overall is valid, and one we as we extend I think this approach, and as people hopefully copy our approach and try to increasingly evaluate models for their ability to represent populations, they'll need to make sure that they're actually representing real human data. And I'm probably not the one to like best speak to all the various like human verification systems, but I think that yeah, that is absolutely a valid concern, and we need to make sure that uh, these yeah the source data is actually representative.
Thank you very much, Evan. Before we head forward to Christoph Wolf's question, here in the QA, they asked you to go back to the last to third slide, the one that goes before what's next. I believe they would likely want to take a screenshot.
Okay, that's the sorry, which
It's
slide?
third
What's
to
that?
last. It's the one that goes before what's next. Thank you very much, Evan. So the other question from Christoph Wolf, it says, thank you. You presented marginal distributions. Do you also test for bivariate or multivariate distributions? How successful are
Hmm.
you in reproducing covariance matrices?
That's great. So I kind of glanced over a lot of or like just presented the high level findings here. The link, if you go to cip.org/digital twins, that'll take you to our preliminary platform where we are uh, testing this stuff out and posting our latest findings. And from there, actually, the findings go into a lot more depth, going into the sort of specific uh, variants in the statistical methods that we've tested with the I think the specific population distributions here. This Yeah, it's there we're finding that in our, at least in the survey data that we're using, um, the there are certain aspects of the survey where, or certain questions in the survey where we know that there are divergences between uh, uh, um, different demographic groups, and that there are um, like yeah, not there are, I guess, but like yeah, yeah, pretty significant divergences. And one of the things I'm exploring is just trying to test more richly the the material where there is known like yeah, bivariate distributions, where there's more spread in the source data, and seeing how models actually, because that's where the richest variance between the demographics is going to be. Um, and that's the best opportunity to really test models and their ability to discern like demographic leaning versus just going to whatever their latent understanding of like the population distribution is. But work in progress. And again, I encourage you to look at the cip.org/digital twins, and look at our currently posted findings there for more details.
Thank you very much, Evan. Carly Lissoff asked you to post that link if you could.
Yeah, there you go. Oops, I'll put that.
Thank you very much. We still should have some time for a few questions if Evan is still available. Okay, so I will read. There is a question from Carly Lessoff. So it says, I realize that your current focus is on simulating responses, but do you have any thoughts about the idea of a digital swim that simulates the survey data collection and data management process with agents for respondents and interviewers, etc.?
Yes. Yeah, this is a great question. So this is, if I understand right, like asking about having your digital twin actually do the survey, like uh, survey collection, and running the interviews themselves. Yeah, so there are a number of companies that are starting to offer these services actually directly. They call it, and you might be familiar with this, call it qual at scale, or like qualitative at scale. And they're starting to introduce basically AI moderated customer surveys or user research, where an AI moderator runs the interview and dynamically responds to how the participant interacts with them. So you can like set up a set of like high level goals that you want accomplished during a survey interview, and key questions that you want hit, or like data that you want collected. But then the AI moderator sort of is able to uh, adjust and dynamically react as the conversation develops, and like poke a little deeper if they want to. And so I think that is a really rich source for, as that expands. And I think that is where you get the richest data. And I think that's increasingly where what surveys are going to look like, is less like poll questions, which is what we're currently testing in our framework, less like poll questions and more like investigative journalism. And I think research institutions around the world, corporations and governments, are going to conduct surveys much more, again, like they're investigative journalists, um, with a really compelling interface interview asking probing deep questions with follow-ups, potentially likely done over video so that they can verify partially that you're human, but also because we're finding that video actually delivers the highest quality participation from participants and some of the most thoughtful answers. And then at scale, sort of parsing out in aggregate what themes were from the respondents. So in that world, yes, having your digital twin or having a good high fidelity representation of the things that you care about from as a survey runner, uh, uh, what are the goals? What are the values you have? What are the boundaries you don't want to cross when you're interviewing people? Is very, very important. So yeah.
Thank you very much, Evan. We have a question now by Claire Durand. So she asks, sociologists say that the relationship between demographics and behavior and attitudes have become much less substantial. If you base your twins on demographics, what is the impact?
Oh, interesting. This is making the claim that the demographics have less to do with behavior and attitudes than I guess other variables, which maybe is I'm curious what those other variables would be. Yeah, I think if that I would love to learn more about that and understand that better. Years ago. Okay. Yeah, I would love to. Yeah, I'll have to dig into that. But I think to me, demographics is more of a placeholder for consistent variables across data sets. And it's just easier right now because surveys, by and large, the consistent variable across survey data sets tends to be demographic questions. It's age, gender, religion, education, income. Um, those are questions that appear consistently across surveys. And so trying to build a large corpus of material to assess models on and to assess how they perform in a consistent way across groups. The easiest thing to group by right now that's consistent across all these data sets is these demographic variables. Over time, if that's become something else, and I hope it does, I think there's, and if you have a large running survey like the World Values Survey, I hope our global dialogues becomes something that persists for a long time. If you have a long running survey, you could treat any survey question as a placeholder for this sort of consistent variable, and you could say that example question I asked about basically people's optimism or concern, excitement about the future of AI. We ask that question in every survey of our global dialogues rounds. And so we could treat that as a group and say, how do people who are excited about the future, how well do models do at predicting optimists versus AI future pessimists? But yeah, I think demographics right now is just kind of a placeholder because it's fairly easy to connect from the data sets we currently have access to.
Thank you very much, Evan. Do you have any more questions here on the chat? You can also ask a question in the microphone if anyone would like. I can open it. Okay, so we have a question by Michael Oshner. So he asks, you assume that people have opinions as such independent on context. Also, these are stable. How would you imagine modeling, or how did you model in case you already did? Dependent development of opinions and preferences depending on who is interacting with whom in what in what context. For example, in academic discussions, some discussants consciously announces such changes with, now I'm asking with my other hat on as a director of the normal population. You can see differences in discussions among men or women only in mixed situations.
I see. I think this is sort of asking about like how, yeah, assuming that the opinions that this data is based on are expressed, the source data is expressed in an environment where the opinions are independent of the context that they were originally asked in, which we know is not true, as like any good survey designer or collector knows that the environment that the survey is conducted in, who conducts the survey if it's done in person, um, the state of mind, or even the framing around the survey itself. You could even be prompted at the start of the survey to like act as if you are a director, or like as an employee of blah corporation, or as a student, and those priming effects like affect your responses. Um, so I think that's, if I understand correctly, that's the what the question this is getting at. Um, yeah, I think that's right now. Yeah, right now this is uh, again, I think just based on we're currently using data that's easy for fairly easy for us to control and I control the source of, because we are also running those surveys separately. Um, uh, but yeah, I think the effect of the survey instrument itself, how it's presented, the context, can absolutely play an effect, and we would want to carry that over to the to the prompt that is given in the model. And so ideally, in whatever we're testing in this framework, we are giving the models as comparable as possible, as reasonably possible. We're giving them as comparable a context as the original survey population. I mean, if there was even such a thing, like we would put the AI model in front, like, because our surveys were done digitally on a website, we would even have the model like sit in front of a computer and go through the website and click on the buttons. Like that would be ideal. And ideally we could even get to that point where we are literally having these AI systems to go through the exact same sort of formulated steps that the surveyed populations go through to really get a comparable context. So I think that effect is real and very much there. Right now, it's not something we're taking significantly into account, but we are trying to give them as much of the original survey context, like the instruction material that the survey participants were given, so that they're in the AI models are in a similar state of mind as much as possible.
Thank you very much, Evan. All right, we can give them, I would say, a few more minutes to see if there's any other questions coming, but because we still have a little bit of time.
So I'll just add to that last that the stability thing is also another thing we're taking into account. We are running these evaluations on a recurring basis, so yeah, I think and the survey data, at least our survey data, is also on a recurring basis. So a lot of the source material is being updated because we run these global dialogue surveys on a cadence of about every other month, and we are working on getting funding to increase the frequency of that and also increase the sample size. And the evaluation of the AI models itself actually runs periodically to update and see how models change their answers longitudinally. So yeah, we're trying to take into account that if opinions do change over time, on both ends, actually.
We have another comment by Carly Lesov. So it says, do you want to say anything about the potential for this process to impute for missingness? An example, not to generate the full data, but in a scenario where only partial data was collected. Sorry if you already covered this. I lost the connection a couple times. Also, can we get the slides and recording or an AI summary? Oh, about that, this recording, this webinar is going to be available at YouTube, WAPOR's YouTube channel. So yes, it says that it's definitely worth it. Again, thank you so much for your presentation. It was really thought-provoking.
Oh, thanks for that. Just on the slides, I will, yeah, I'm glad. Thank you to WAPOR for recording this, and I will also make these slides available. If you want to email me, I can share them. I will find a way to make them available in a more public way as well. But on the potential for this process to impute missing data, I think this is totally a process that can be used to impute data, gaps in data, and I think that's part of the world modeling and I alluded to that, where I think at scale what you're going to see more of is not necessarily just I think you will see full on just simulations, just trying to simulate populations at scale without human input. But I think what you're going to see more of actually is running simulations of populations, world modeling, with a kind of human accountability or human in the loop, where you are constantly validating the simulation results against a representative sample of the human population, and checking, like validating and even reporting on the accuracy of your simulated results based on the how it corroborates against the human sample. And to me, that is a form of like imputing missing values in a way that you're and I think you can sort of like imagine using that same sort of dynamic to fill in missing data, even retroactively, and we might try to do this to fill in gaps in historic survey data, answer questions that we didn't get to ask in previous surveys, and try to report or estimate the level of possible accuracy on historic populations is I think a really interesting application of this.
Thank you very much. Once more.
All right. Well, yeah,
All
thank
right.
you. Yeah, thank you so much for the opportunity and for the stimulating questions and conversation from this. Yeah, this has been a joy to present on and share a lot of things we're thinking about.
Thank you very much, Evan. Thank you very much for all the attendees. This webinar is going to be available at YouTube, WAPOR's YouTube channel. And once again, we're very happy to have you here and hope to see you again soon.
Thanks all.